Hi everyone, good morning. So I'm Aswin. I work for Red Hat. So from past yesterday morning, you have been hearing so many sessions related to network. So this is like one such service in network, and this presentation mainly deals about security group implementation or how it is done in the network. So first of all, thanks for the slides, for the network team for the slides. I have taken many of them from the advanced session presentation that we did in the Seattle Summit. Okay. So a brief intro of the session. So this mainly covers about like how security group implementation is done in the network. It deals with the new network or the VPN service-based network. It doesn't cover the legacy or what we had in the previous release. Also, it deep dives into various modes. We have 3 modes of implementation supported. It's based on like different requirements or the limitations of OVS. We have 3 different modes. You can use any of them based on your setup or the OVS you use. So we'll be going through each of the pipeline a little bit in detail, like the pipeline specific to the ACL service in each of the modes. So that also will be covered as a part of this presentation. So let me go to the next one. So this is just the overall architecture. You might be seeing it from past one day in several presentations. So ACL service sits, somewhere here. It's like we mostly respond to the VM creation or the port creation, and we'll add the rules or configure the rules which was associated, or the security group, based on the security group which was associated to the VM, will configure the rules. So most of the rules are configured when a VM is spawned, and when you modify certain groups which are already applied to some VM, we'll have some flow from the north as well. So mostly it is from on the port creation we program these rules. Okay, so yeah, this is a big figure. This is the Dragon team. So we'll not be covering the entire part. Many of these are already covered in various sessions. So only this yellow boxes is that was going to be covered in this session. So in the pipeline. Okay, so some basic intro about the implementation. So the implementation is based upon IETF access control list model. So this helps in like future expansion of this service for non-net or non-OpenStack use cases as well. Currently it is implemented only for OpenStack, but this uses a generic model, and we have did some changes in the model for OpenStack use cases, but generally when most of the model is from the IETF. It supports the port security extension driver. So this is basically something, maybe there was like some session about SFC before. So when you use service VMs and all, like you don't want port security to be enabled for a particular port, because it will do add anti-spoofing rules, which will prevent the VM which is spawned acting as a DHCP server or something. So this is basically a parameter which, if you disable this, that particular port will not have port security enabled, and all the traffic will be allowed by default. So this implementation supports allowed address pairs as well. This is something like, as it was mentioned in yesterday's sessions also, so like a VM can have more than one IP address assigned to it in various use cases. So if you if you configure that allowed address pairs, it will allow traffic from that set of address pairs, but not from any other combination. The address pair refers to the IP MAC pair. So the VM will have a default IP MAC pair, and you can add more of them. So if you add more of them, all those combinations, traffic will be allowed. So this is like anti-spoofing rules. Anti-spoofing rules, as I told, like it will be added by default. This makes the VM restrictive. As it was mentioned, it is not as restrictive as OpenStack currently, but it restricts only by default. It allows only DHCP traffic and ARP traffic to go through. All the other will be blocked if you doesn't associate any security groups. Okay, we'll come more to it later. Yeah, it supports all the neutron CRUD operations like create, update, delete of security groups dynamically. All are supported. Yeah, this is some detail of the implementation. The port range, when you want to allow, it's a case of TCP and UDP. Say when you want to allow traffic from a range of ports from 1000 to 2000, maybe you have some protocols which uses the ports in that ranges. So in that case, when we use the Nicira port mask, we can reduce it from 1000 flows to like not comparing each and every port. We'll use the port mask and reduce it to say a set of 4 or 5 flows. So that's also used in this. So next, the different modes that's available. So first mode is the stateful mode. So stateful mode uses the contract or the NetFilter framework, which is available in the Linux kernel. So OVS have this integration with NetFilter. This feature came as a part of OVS 2.5. So you require OVS 2.5 to use stateful mode. And when you install OVS 2.5, you will have to install a kernel module also, which when you go through the installation steps, there is a way to compile and create a kernel module. You have to install that. So then only you can use the stateful mode. This semi-stateful mode or the learn-based mode. So this mode is this is like a mode which learns the. I'll come to it more detail in later. So this mode learns the reverse role or the when a forward traffic is allowed, the reverse traffic, the rule to allow reverse traffic will be automatically programmed in the pipeline. So this rule is based on that, and this mode is supported in OVS well below 2.5 or 2.4. So you can use it if you're having a lower OVS or you don't want to install the kernel module. Also, the OVSDB currently does not support the NetFilter or the contract integration. So we'll have to use learn mode in that case as well. Transparent mode is just nothing; it just disables the SG feature. So it will allow all the traffic, and the rest of the pipeline will take care of the traffic. And there is nothing. This ACL service will not do any filtering on the traffic. So these are like the configuration entry you have to make to change the mode. I have added one slide like how you can change the mode. So the next slide speaks about that. So this is just a step. You can go through it, the slides. So you have to create a one way of doing it is like you can create a folder or the directory structure before, like once you unzip the release, and you have to make change this entry. So by default, so this file you can the file with this name you can just create a random file and you can just put this entry, and here you can mention the load the mode you want. So by default it is stateful. So if you want stateful, you can just like bring up the graph, or if you don't want any other mode, you have to change it here and then start your graph. So now we will go a little detail into the stateful mode. This stateful mode, this is out of the implementation. This is expected to perform much better than the other implementations. As like once you have a traffic or connection established, it executes much lesser rules than the other one. Also, the switching between the kernel module and the OVS is much faster. So this is supposed to be the most performing one among the other among the implementations. So the packets are connected. Submitted to the Linux NetFilter framework. I have next slide to talk in detail about that. So NetFilter framework helps us in tracking a connection. Then to track a connection, okay, let me go to the next slide and come back. So all this connection tracking or statefulness we need because say like we are allowing a traffic egress, okay, and it went out. Now you will get a response for this traffic. So by default, as I told, like Openstack is or the SecurityGroup implementation is restrictive. If you don't have an explicit rule, all traffic will be dropped. So now you are having an egress rule. Think of that. Like so, the traffic goes out of your VM. But since by default you don't have an ingress, the traffic will be dropped by default. So this statefulness will help you in understanding that. Like if you have initiated a connection from your VM to the egress, all the return traffic from that will be accepted by the ACL service. So to do that statefulness or to track that connection, we are using something called the NetFilter framework. So let me go through. So you have started a connection and you are now pinging or sending an ICMP traffic out of your VM. So once you go do that, it goes through various stages. Like first, when the packet enters the OVS, right? So now when a packet is newly entered, it is untracked packet. So this has never been sent. What untracked means is like it just entered the OVS, and this NetFilter framework is a part of kernel module. never analyze this packet. I've never seen this packet. So what OVS will do is like OVS has a CT action. This will come as a part of a rule in the ACL service tables. So this will submit the packet to the NetFilter framework. So now NetFilter sees, okay, is this connection existing? So if it's your first ping packet, it's not an existing connection. So OVS will return you like, it can return you any of these 4 states. So in the first case, it will return you like, okay, it's a new packet. I have not seen this before. So now it will go further to see whether there is any rule which allow this traffic. So as I told earlier, in our case now, we are allowing egress traffic, ICMP egress traffic. So there will be a rule which will allow all new ICMP traffic that will be there in the pipeline. So based on that rule, we will allow the traffic egress and the traffic goes out of the VM. So besides allowing the traffic, what we will do is like we will do a commit here. So what we will tell like is like we'll mark the NetFilter like I am allowing this connection, please mark this connection. Now if the ping goes out to some external entity and it comes back, the ping replay comes back. So now when you send it again, so when it enters OVS again, we'll again send it to the NetFilter. Okay, is this a known connection? So in that case, it will return, yes, it is. It's a plus track plus established connection. So now you don't require any explicit rule to allow it. So all the plus track plus established will just like that allow, so that the other tables can do the appropriate action. So like this, we will achieve the statefulness using the NetFilter. So just to go through the other modes as well, other states as well, plus tracks plus relative is something like if you have allowed one connection, the related connections also will be allowed. So one example like I always give is like the FTP connection, and when you establish a control channel, the data channel connection will be related. So if you're allowing one, the related connections also will be allowed by default. And plus track plus invalid is like a packet which is invalid at that point of time. One such example is like if you have a TCP handshake, 3-way handshake, and you are sending an ACK without a SYN. So the packet will be marked as invalid because this is not expected at that point of time in that connection initiation. As one example, there are several other examples like if the packet is malformed or something, it all will be invalid. So yeah, this is 2 CT actions. One I have talked, like one is just to send it to the CT for knowing whether it is a new connection or it's already tracked, or like and this one is like when you are allowing a connection, you will mark an entry in the NetFilter, okay, this is a known connection. So these are the 3 stages. So coming back to this slide again. So how each individual connection is tracked. So individual connections are tracked based on like this tuple. It includes layer 3 protocol, source address, destination address, IP, layer 4 protocol, and layer 4 key. This layer 4 key can be varying based on like ICMP, it can be code and type. For TCP, it is the port number, destination and source port number. Also, the implementation uses something called CT zone. If you have seen, it is there here. So CT zone is something like to address overlapping IP address. So if you see here, like this tuple. So if we have overlapping IP addresses to different connections from two different VMs can have same values for these tuples. So now we are tracking each connection from each network. It's based on ELAN ID in separate zones. So one connection in one zone will not affect or like will have different entities for different entries for tracking overlapping IP address connections. So some of the issues with the stateful mode is like it doesn't support OVS2.5 less than OVS2.5, as I told already. It will not support contract. DPDK, it's expected in 2.6. We have not tested. Maybe it's already there. Also, the kernel modules, you have to load it. It's not available by default in the Linux kernel, which is less than 4.13, I guess. Yeah, that's about that. Now we will go through the pipeline once. So this is how it comes. Like, so it comes to the classifier. This might have interesting. So it comes to the dispatcher table, and now it will come to the ingress ACL. One thing I have to tell is like this ingress and egress is with respect to the switch. So it's like if you consider it with respect to the VM, it will be the other way. So all the traffic coming out of the VM will first hit the table 40. So first it will send it to the NetFilter to see whether there is an existing connection or not. Then it will be submitted back to table 41. Here it will see what is the state of the packet, whether it is plus track plus new or plus track plus established. Based on that, if it is plus track plus new, we require a specific rule to allow this traffic. If it is plus track plus established, it will be allowed and it will be resubmitted back to the dispatcher. Then it goes through all the service, whatever pipeline we have seen in the initial slide. Then it will come to table 220. Now, if this traffic is to a VM which is in this OVS, it will hit these two tables. If it is not, there will not be an entry to direct it here, it will directly go out. So it's again, egress also, this 251, 252 also works the same way. First check with the NetFilter, is this connection existing? Yeah, then here it is checked. If it is established, it is allowed and submitted back to 220 and 220 send it to the output port. If it is not, it is and it doesn't have a specific rule, it will get dropped here. So these are some rules. I think it's a little small here. Maybe I have some slides with a better resolution. So this is just the description of what I have told already, the path of a ping packet when it hits through the rules. Okay, so we'll see the flows more into the little more later. Now we'll go to the learn mode. So as I told, like the same case, like when you are allowing an egress, you require the traffic coming back to be allowed by default. So one way is that what we have already seen is used to use the stateful mode. Now this is another way of realizing it. So how it is different is, right, this achieves it through something called as a learn rule. So along with the rule you add to allow the traffic, you will have one more action. One action is like submit it to the next table and go through the pipeline and allow the rest of the pipeline, and if the allow the traffic. So here what it does, like beyond allowing it, it also adds a new rule to the other table. So if I come, the tables is little different for the egress and the stateful and learn mode. There you saw only two tables. Here we have three tables. Okay, so what does it here? It does is like if you are allowing a traffic here, you will dynamically insert a rule in the other table to allow the return traffic. So if you are allowing a traffic outside the VM, you will program a rule in the ingress pipeline to allow a traffic inside. So this program rule will have a timeout. Say it is configurable. It is higher for a TCP because in TCP case there can be a connection without any traffic for a pretty much long time. But it's little less for UDP and ICMP. So by programming this rule, we will allow the reverse traffic. So we'll go to the flows later. So yeah, then one more thing here to talk is like there is when you program a rule, you cannot have an output action. Just like because only output action allowed is like to output to a port. But we have a very big pipeline and we have further processing that needs to be done in the further pipeline. So what we are doing here is like in table 40 there is just one rule, submit it to 41 and submit it to 42. This is something unique in this flow. We are resubmitting twice. So first it will be submitted to 41, and sometimes 41 will have a rule, and sometimes it may not have any rules because it's dynamically programmed. So if initially when the traffic comes, it will be an empty table, but later when traffic goes on, like the more rules will get programmed. So first it will send to 41, and if 41 has any entries, it will load a register, say with value 1. And in 42, first thing we'll check like whether this register is loaded. So you can just relate it to the previous mode we had discussed. So there we were submitting it to the NetFilter framework, and NetFilter was marking it plus track plus new or plus track plus established. Here, this table will mark. If it is a new one, nothing will be loaded. If it is an existing one, one registry entry will be loaded, which indicates that this connection is already existing. So like that, we were just like that allowing plus established connections. Here, if that register is loaded, we'll allow the connection, or else you require a specific rule to allow the connection. So yeah, so this rule you can use in OVS less than 2.5, this mode you can use in OVS less than 2.5. And it's like, though it's semi-stateful, it's almost a complete implementation, because in legacy network we had something based on TCP SYN. It was only for TCP connection, but UDP and ICMP were never filtering. But this is an almost complete implementation. So this is how a ping packet travels. Maybe you can see it through this. So as I told, ingress is with respect to the switch. So when with respect to the VM, it is the egress. So when a traffic comes first, it will hit that, we can think like a ping from one VM to another VM. So it will hit first the table 40. So this is the first packet. So what it will do is like it will resubmit twice. It will resubmit to 41. This is the first packet. There will not be any rule in 41. So it will go to the table 42. Now in 42, we should have a rule which allows ICMP traffic egress. So when that rule is hit, there will be a rule which gets dynamically programmed in table 252 to allow the return traffic. Now the traffic goes to the dispatcher again, because it's an allowed type of traffic. It will go through all the other pipeline. It will come back to the egress. Since it's to a VM in the same OVS, it will hit this table. Now again this table first it will hit this table and it will be resubmitted twice. There will be a rule which was inserted by this guy, but it will not match this time because the destination IP is different, and not destination MAC is different, or the LPO tag is different. And it will come to 253. Now 253, it should have a rule which will allow ingress traffic to the VM destined. That we should have, because that VM should allow a traffic ingress. So now that guy will insert a rule to this table, that is the table 41. Okay, and it goes to that VM. When it comes back, the traffic comes back from the VM. First it will hit the table 40. Now it will come to 41. There was a rule that got programmed here, so it will load the register. So from 42, there will not be any more checks. It will be just like that allowed. Similarly here also, it will be 251. 252 will have a rule. So 253 will see that the register is loaded. So it will go to the egress and it will go out of the pipeline. So this is how learn mode works. And next mode is the transparent mode. Yeah, this mode is like mostly used when you are blocked with SG or like you have some deployment issues, like you want to test it and somehow you are hitting some issues with SG and you cannot resolve it. So this is mostly used like when there is some bugs, or like you don't want SG at all. Let me test my stuff. I don't want this SG to be interfering with my packets. So this is some mode. This is not intended for users in deployment most of the time, because it disables SG across the deployment. It's not like per port. It's like this SG is not supported at all in this deployment. So yeah, this is like now used in many of the maybe I think in the CSIT stuff and all. This is used because there are some infrastructure limitations. But soon we'll plan to change to other modes, stateful, and maybe two set of one with stateful and one with learn. Yeah, so that is about the transparent mode. So this is some metrics I have added, because like there will be a lot of queries that used to come, like what are the rules I should add to, because when you spawn a VM, whether it will work with the VM to VM ping will work, or like with DSCP namespace to VM ping will work. There used to be a lot of confusion. So this table just talks about that. So transparent mode as it is, it's all success, because it never filters any traffic. Now when it is no SG, so when you spawn a VM using Neutron CLIs, you have done it, might have seen like there is no need to explicitly specify a security groups, it doesn't mandate it. So if you don't specify anything, it will associate something called default SG. Okay, so this will be the default behavior when you don't explicitly specify. Now, so after spawning a VM, you can remove the SG as well. So if you remove the SG, none of this traffic will work. Okay, so that is the first case, like where there is no SG associated with the VM, all the traffic will be blocked. VM cannot ping anyone. Only traffic that will be allowed is DSCP traffic, so that the VM will get an IP. ARP also is allowed.
rest all traffic is blocked if you don't have any SG. This SG, it will get associated if you don't specify anything. So this allows traffic between the VMs which are all in the default SG. So if all the VMs here are in default SG, you can ping them. Also external, it allows anything. So you can ping from the VM to the external network as well. But if you try to do any ping or SSH from the external, like DHCP namespace, towards the VM, if it is a stateful mode, it will fail. You will require a specific rule which allows SSH or ingress inbound. So that will fail. In learn rule, the implementation is such way that this will succeed as of now, because we are not comparing the IP where the traffic originates as of now. But the OpenStack rule mandates it should be only from the VMs which belongs to default SG. So it fails in the stateful mode. Now if you want external traffic to be allowed, you can add this rule set. I have just mentioned 2 rules. So here it is like from port 22, ingress traffic. This default is the security group name. It's the OpenStack default security group's name. So allow SSH traffic ingress and allow ICMP traffic ingress. So if you add these 2 rules to the default SG, you will be able to communicate from the DHCP namespace to the VM. Again, if you try some UDP traffic comes, since there is no rule, it will be dropped. It will be a fail here as well. So this is about that. Just a matrix, maybe you can refer it like whenever your ping is working, not working, or like some traffic is getting blocked. SG can be the primary suspect. Okay, this guy is blocking it. So you can just see whether you have these rules associated it, and the traffic pattern is, or it is according to this matrix what is happening. Okay. So now I'll go to some of the flows. Okay. So this is like I'm creating a network of excellent type and one subnet, and I'm spawning 2 VMs. So as I told, like I'm not explicitly specifying any security groups. So both the VMs will have the default SG associated with it. Okay. So these are the anti-spoofing rules, whatever I told. So these rules will get programmed. If you don't associate any security groups or associate, these rules will be programmed if you are enabled port security in that port. Okay, so by default, all the VM port will have, if you have enabled it in the neutron port security, all the neutron port, all the VM ports will have security group enabled, and all the router ports, DHCP ports will have it disabled. So these rules will not be programmed for router and DHCP ports. All the other ports will have, all the VM ports will have these rules programmed. As you see, this is like allowing UDP traffic, allowing ARP traffic, and some of them are like the ICMP traffic rules, which are required for the ICMP, messages that will be exchanged, or either IPv6 messages that will be exchanged. I think Sridhar has already covered it in yesterday's session. So those rules will be added by default. So now I'll go to the next set of rules. So now some more rules will get programmed automatically when you spawn a VM. So, and for both the modes, it's slightly different. These set of rules are like same for both the modes. You'll get the rules get set, or the anti-spoofing rules looks exactly same for both the modes, and the other rules are little different in the individual modes. So when you just start the ODL, there will be some rules that get installed. This is not port-specific rules; these are generic rules. So these rules, like as we discussed earlier, this is for the stateful mode. Plus new plus established, always allow. Plus new plus related, always allow. So we are not checking from which port it is coming or nothing. If it is the NetFilter tells its track, we are just like that allowing it. And invalid and new, we are dropping. So if you don't have any other connect rules to allow traffic, this will be the place where your traffic will be getting dropped. This is the default drop rule. Okay, so you can just check for this rule if the traffic is getting dropped, whether it is getting dropped in 41 or the 252 plus track new drop rule. Okay, and these are the other set of rules. It comes in one table as is 41. This is in the table. This is in table 40. This is just to send it to the city framework. But this is added per port here this allowed IP MAC pair comparison as well as happens. Here it checks for the MAC and the IP. So we will send the packet to the NetFilter only if it is from the designated IP MAC pair, and it will be resubmitted back to table 41, and here we check for the connection tracking states. So this implements the allowed IP MAC pair as MAC pair, and also submitting it to the NetFilter. There is a drop in this table as well, so that was here, I guess. Yeah, table 40 has a drop default. So if you don't have any matches in these rules, your traffic will get dropped there. In learn, it's slightly different. When you start, the first table or the 40 table will have 2 resubmit. This is what I told, like since there is a limitation in the actions you can have in a learn rule, we are resubmitting the packet twice. First we'll go to 41 and 42. On startup, there will not be any entry in table 41 because there was no traffic yet. And 42 has a 2 default rule. One is like if there is a regex loaded, allow the traffic by default. If nothing, drop. So here also there is a default drop. So if you don't have any rules associated, it will get dropped. So now I'll go to default SG. So these are the rules in default SG. So first rule speaks like egress. I'm speaking about default SG because this is the one that will be associated and mostly seen in your when you start a VM, because most of the VMs are in testing and all, you will just like that start. You don't explicitly associate any SG to it. So the first rule speaks about like egress, any traffic, from any IP prefix allow. That's why like if you want to communicate anything outside, default SG allows it. Now ingress, it's a little restrictive. So ingress, it allows only other VMs which have default SG configured. So if there are 5 VMs and 4 VMs have default SG configured, and in the 5th VM you have created your own custom SG called SecurityGroup 1, and the 5th VM is spawned with SecurityGroup 1. So all the 4 VMs will be able to communicate with each other, but the 5th VM which was spawned with SG1 or SecurityGroup 1, and it had some rules which allows, maybe the similar rules which allow traffic, remote traffic from SG1 or something. In that case, that particular VM will not be able to communicate with these 4 VMs. Okay, so this remote group creates a set of VMs which belongs to one cluster or something like, which can communicate between each other. So yeah, so there is a set of similar like IPv6 rules also, which will allow similar egress, anything IPv6 traffic will be allowed. Ingress, it will be allowed only from the remote. So I'm not discussing, it's like it looks exactly the same. I didn't want to have more flows here. So I'm speaking about only IPv4. Now in stateful mode, so now we are spawning a VM. You will see all the other flows. It will be like when you spawn a VM 40, 41 and 241, like I have a huge set of rules. But only these 2 rules are like programmed in response to a security group. So the first rule, or the table 41 rule, it corresponds to this egress IPv4 any rule. So what it does is like, as I told, this is plus track plus new. So if it is a new packet coming for a new connection, and it matches this LPO tag, and if allow this connection, like resubmit to 17. Along with that, mark an entry in the NetFilter like this connection, any further packets in both the direction, allow it. So now if you send again to the NetFilter, it will tell like, okay, this is an established connection. So this is some kind of committing the connection to the NetFilter. And since both the VMs are spawned in the same network, they have the same zone, 5000, 5000. If it was in different network, it would have been a different zone. Okay. Similarly, in 252, one more rule, this is corresponding to this security group rule. So here you can see something different. Here, like beyond comparing the LPO tag, it's also comparing the network source. So we have 2 VMs. So it will allow only traffic from the other one. So if it is a traffic destined to 10.4, the network source should be 10.3. Then only it will be allowed. Vice versa. If it is traffic from 10.3, then the to the 10.3, then the network source should be 10.4. So this is like added due to this grouping of the default. So this like if you have 3 VMs, we'll have all the combinations. like 10.3, 10.4, 10.4, 10.5, 10.5, 10.3 like that. So like as you have more VMs, the number of rules also will increase, maybe more, or like maybe exponentially I can tell. So because like it's comparing each and there is no grouping and all, we are just like that, just creating something like of a mesh kind of rules where all the possible permutations are there. So here now only since 2 VMs have been spawned, only two rules are there. If it was 3 VMs, it would have been 6 rules altogether here. So due to this check, any other traffic other than which has a source IP 10.3 or 10.4 will be dropped. That will be done by the default drop. And so this is the stateful implementation of the rules. Now if you take the learn one, okay, if you take the learn mode, you can see like corresponding to table 41 here, it is a table 42. So here it is like all the same, matching the LPO tag. And here one action is resubmit. So here we are seeing commit city zone. So here instead of committing it, we are just learning a rule. So we are adding a new rule. If this is a 42. So this is this is table 42. So we are adding a new rule to table 252. So if you go back here, yeah. So here in 42, and we are learning a new rule and putting it into 252. So now when the return traffic comes, this the rule in 252 will allow the traffic. So to allow the traffic, we are now just doing this destination source swapping, because the reverse traffic will come from the destination address will be the source address and the source address will be the destination address. So we are swapping that to add the rule, and we are also having a load action. So what is the load? This will load that register with the value 1. So if you remember in 215, 43 or 252, we are checking for this particular field, whether it is loaded. If it is loaded, traffic will be allowed. So yeah, so there are like 2 rules getting added, like similar to the stateful mode, and this is the rules corresponding to the second rule. And here little different is like we are not comparing the network source here. We are just like allowing all the traffic. So that's the reason we are seeing a difference here, like why this fails here and that doesn't fail here. Currently we are not comparing the source address there. Rest all, it looks same, like this will insert a rule in the 41 table to allow the return traffic. Okay, now this is about the custom SD. As I told, like if you see that metrics, like by default, if you want to ping from the DHCP namespace, as most of you will be like when you are connecting to a VM, you will use DHCP namespace to SSH. Otherwise, maybe web manager, or you can use the DHCP namespace to connect to the VM. So by default, if you have default SD, it will be dropped. So if you want to connect from DHCP namespace or something, you have to add these 2 rules extra. So this here I'm just adding the port 22 and HTTP and SSH connections. So the corresponding rule will get added. So as told, it's similar to whatever we have seen. Earlier it was just IP here. We are just matching IP because it's a protocol, can be anything. So it doesn't matter whether it is TCP or UDP. So here we are allowing only TCP. So here there will be more check here to know whether it is a TCP connection, and it should be from port 22. And since we are having default here, we will have that IP check as well. Now learn mode, it's all the same. Whatever we have seen in the previous slide, instead of IP it is TCP, and it compares the ports as well. So so you will require this rule if you want to. I have added this to default SG only, so you need not create a separate SG for this. It's like it will get added in the default SG itself. So all the spawned VMs will get the connectivity to DHCP namespace if you add these 2 rules. So yeah, with that I finish my presentation. So if you have any questions, you can ask me now.
The connection tracking in contract, does it also track the TCP window and the sequence numbers of the TCP connection? Or is it only just a state established or?
Uh, uh, Not exactly. It's just like what we want is like maybe initial handshake it checks, like the complete handshake should be there. Then only the connection will get established. After that, the packets will like windowing and all will be taken care at the different level. And once the packet reaches OVS, it will be just used for tracking it, whether it's an established or it's a new
Yeah,
one.
so I mean, it basically tracks the SYN packets and acknowledgement packets and just see if the connection is established or not.
Yeah.
But if it doesn't check any sequence numbers of the TCP
Yeah,
packets. It
yeah,
doesn't
correct.
go deep into that. So is there any plan to support it in the future OVS releases, or is it going to be only this basic support?
I think, is there a use case where we require it? I'm not sure about it because NetFilter, we are just using it for the state of the connection. Rest all will be taken care at a different layer altogether, right?
Because I mean the contract itself is almost similar to a full-fledged firewall itself. So it already supports the TCP window and all, and if the NetFilter is able to pick those up, we can span this as a full-fledged firewall itself instead of going for another physical firewall device.
Okay. Okay, currently it's not planned, maybe it will come. Thank you.
I have a question. Now, say for example, you have a VM and you have a default security group. So all the outbound or the egress traffic is allowed. The VM establishes a TCP connection to an external machine. Traffic is flowing. Now I delete the flow. So there is already a connection tracking entry in the kernel. Now what will happen in that state?
Yeah, I got it. It's a good question. So currently, if you already have a connection and if you dynamically remove from the rule from the OVS, the connection will continue. If you are pinging and if you just remove the rule, because the OVS does not have an API right now through which we can refresh that connection tracking entry. So the connection will go through. So we do have a plan to address this. One way we were thinking is like to add whenever like you are removing a rule, you will get a notification from Openstack, and in response to the notification, you will remove the rule. Also, we'll along with removing the rule, we'll add a high priority rule, which will have a timeout, hard timeout or idle timeout, after which it will expire. So that higher priority rule will drop the traffic. So before sending it to the CT framework in the table 40 or 251, we'll just like that we'll have a higher priority rule drop. So this packet will be dropped and it will never be sent to CT framework. So we'll match the timeout such that it is similar to whatever connection tracking framework has, so that from when this rule times out, the connection times out in the NetFilter framework as well. So in future, if OVS comes with some API through which we can flush the connection, we can think of using that as well. But in learn, it should work, I guess. I have not tested it, but it should work, I guess, because the rules will be removed in both the directions. Any more questions? Okay, thanks for attending.